Hey, this is Jack Jackson. This video, we're going to talk a little bit about David Hilbert. Hilbert was probably the most influential mathematician of the late 19th and early 20th centuries. When it comes to more modern mathematicians of the 20th century and 21st century, um, we have a couple problems in going over them. Number one, there's just so many important mathematicians of these times. And number two, it's a little bit hard to know which ones are the most important when you're looking at history until you get a little bit removed from it. But without a question, David Hilbert is a giant in this in mathematics, and I would consider him one of the top, 10 or 20 mathematicians of all times. He was born in 1862, died in 1943. He was German. As I said, he was the most influential mathematician of the early 20th century and one of the top mathematicians of all times. He grew up in Königsberg. In 1880, he attended the University of Königsberg. There, he became friends with Hermann Minkowski. When he was in graduate school, he became friends with Minkowski. Minkowski was able to lay the mathematical framework for the theory of relativity, so he was pretty important as well. Hilbert ended up doing his graduate thesis under Linnemann. Linnemann was the first to prove that pi is transcendental. He attained his doctorate in 1885, and by 1895 he became the chair of mathematics at Göttingen, and that was a position he held until his death. Um, One of the last generalists, he was able to work in many fields and do major work in many fields. He worked in geometry, invariant theory, algebraic number fields, functional analysis, integral equations, mathematical physics, and many others. His first important paper was about invariant theory, where he proved a basis theorem, that's Hilbert's basis theorem, which is important. He's known nowadays for Hilbert space. So there's a mathematical object named after him called Hilbert space. It's an infinite dimensional space. He did work with algebraic numbers and class field theory. And in geometry, he was the most influential geometer since Euclid. That's a pretty powerful statement because a lot of important mathematicians have worked on geometry over the years. He ended up formalizing a modern, rigorous, synthetic approach to Euclidean geometry, and Hilbert's set of postulates for geometry really went back and cleaned up the axiomatic foundation of Euclidean geometry and put it on what we would now consider today as a modern, rigorous footing. Um, and so his geometry book is based on this. This has become really the foundation for all uh, geometry study really since the time uh, of of his publication of that, uh, which actually happened right at the end of the 19th century. I think in the last maybe a couple years before the end of the 19th century. I have some videos in my geometry notes, my geometry playlist, where I talk about Hilbert's postulates for geometry and talk about them a little bit more. And so you might, if you're interested, you might start by looking at those and then go on, of course, to study more about Hilbert and from other sources. In the year 1900, he submitted 23 problems. And these 23 problems or areas of mathematics that he thought needed to be researched were designed to do what he wanted was to drive mathematical research within the next century. And actually, it has continued to drive research a lot until this day. He said these are important problems. They're going to be important for us to solve, and if we solve these, the work that's going to be done in solving these is going to spur a lot of mathematical growth, and it has done exactly that. Some of them have been solved now, and at least a couple of them are important still unsolved problems. He finally retired in 1930, but he continued to lecture part-time until 1933 and 34 when the Nazis came to power. And I want to give you a quote, actually. This is a quote I ran across in the Mac Tutor History of Mathematics, and is a quote from Otto Blumenthal, which was one of Hilbert's students. By the way, Hilbert taught a lot of very, very famous students, um, and many of them were to go on to great prominence. I'm not going to try to list them all here, but he had a lot of great students, so he was an influential teacher as well. Here's what Blumenthal said about him. In the analysis of mathematical talent, one has to differentiate between the ability to create new concepts that generate new types of thought structures and the gift for sensing deeper connections and underlying unity. In Hilbert's case, his greatness lies in an immensely powerful insight that penetrates into the depths of a question. All of his works contain examples from far-flung fields in which only he was able to discern an interrelatedness and connection with the problem at hand. From these, the synthesis, his work of art, was ultimately created. Insofar as creation of new ideas is concerned, I would place Minkowski higher, and of the classical great ones, Gauss, Galois, and Riemann. But when it comes to penetrating insight, only a few of the very greatest were the equal of Hilbert. So it's kind of interesting that Blumenthal is looking at talking about different ways of measuring, greatness, I guess, in research mathematics. There are those people who go out and create something very innovative and new, like Galois, for example, which ends up eventually becoming revolutionary. And there's others that are really good at assimilating uh, all knowledge that is known or a bunch of knowledge from different areas. And this is where Hilbert uh, was able to excel. And of course, there's some that are known as great teachers who are influential because of what they were able to pass on to the next generation of mathematicians. There are those who are just naturally brilliant, um, perhaps overcoming a lot of um, adversity. We're going to talk about Ramanujan in the next video. He comes into that classification. But Hilbert was absolutely amazing when it came to all of the things he could do. He was one of the last real generalists. Um, if there was anyone after Gauss who actually had a pretty firm grasp of all the mathematics of his day, it would have been Hilbert. Um, and he made significant contributions into a variety of different areas, but he was apparently especially adept at putting ideas together and seeing how they fit together. So, uh, fascinating man, David Hilbert. He is definitely worthy of some more attention.